Okay, so question 4, it doesn't specifically tell us what it wants us to do here, so you've got to work out which statistical test you're going to use. So you've got two different groups of data, so the HL and the SL, and you're going to do some sort of hypothesis testing, so that's like your chi-squared or your t-test. And you're looking to see if the SL perform better than the HL students or not. So this question is a t-test question. So you should have been using the t-test. And it's a two-sampled t-test. So we've got two different samples, and we're looking to see if they're the same or if there's a difference between them based on the sample of SL or HL. So the first part is to state the suitable null and alternative hypothesis. So the null hypothesis is going to be the H0, and that's that they are the same, that the SL and the HL scores are exactly the same as one another. So HL and SL scores are the same. And the alternative hypothesis that we're testing, that's wondering whether the SL students do better. Okay, so that's in the question. So SL perform better or get a higher score, whichever you want to use, than HL students. Some of you wrote things like, for the first one, you wrote that the mean of the first one is equal to the mean of the second, and the mean of the first is bigger than the mean of the second. This would be okay if you'd defined what mean 1 and mean 2 are. So if you said that the mean 1 is talking about the SL scores and that the second one is talking about the HL scores, then this would be okay. But if you've just got that written down, then we can't use it. So part B is asking us to write down the p-value for the test. So I'm now going to use my GDC to help us to work that out. So to use the t-test, I go to Menu, Statistics, Stats Tests, and it's a two-sample t-test. So two-sample t-test. And it's asking me for the data or the statistics, and I want to use data. So to be able to use this, I need to plug in or give the information to the GDC, the actual data. So I'm going to open up a spreadsheet to write the data down first. So I've got my SL scores and I've got my HL scores. So the SL scores are 4, 8, 7, 10, 8, 7, and 5. And then the HL scores were 4, 3, 6, 9, 5, 3, and 2. And now I can do that same process. So statistics, stats tests, and two-sample t-test. And again, I'm using the data that I've input in. So the first one, my first list is my SL scores, and my second list is my HL scores. The frequency of 1 just means that each item comes at once, which is correct. There were 7 people and I've given each of their scores separately as like raw data. The alternative hypothesis is that the SL students do better, and therefore we're taking this option where the first group, the SL, do better than the second group, the HL. And I always need to select yes on pooled. And then I've got my p-value, which is given to me. So the p-value for the t-test, which is 0.03025. So again, to 3 significant figures, that's 0.030, and then that's going to round up to be 3. So that's my p-value to 3 significant figures. And then what conclusion must we make if we tested at a 5% significance level? So this is really similar to the chi-squared one that we just did. So if you draw your graph of the t-test, then you've got your significance level, which is a 5%. It says we're doing it at a 5% significance level. So this is my area, which is 5%. Now the area that I found, this is 3.03%. So it's much smaller. okay? And therefore, similar to the previous question, the area that I found is smaller, it was 3.03%. This is where we decide whether to do the alternative or the null, which is off the original 5% value. And therefore, we can see that because the p-value is smaller than the significance value, we want to take the alternative hypothesis and we're rejecting the null. So we're going to reject the null hypothesis and we're going to accept the alternative. Okay, and any sort of working to back this up, whether it's a diagram or whether you're saying that the p-value is smaller than the significance level, or the level of significance, okay? And then it says, how does the conclusion change if we actually tested it against a 1% significance level? So if you imagine this time, we're looking at a 1% significance level. So this is an area of 1%. Now my area is 3.3%, or 3.03%. So this time, my kind of boundary to take the null or the alternative hypothesis has changed. And this time I'm going to accept the null hypothesis. So I'm going to accept H0. Okay?